This is the first section in Unit 1, which is 4.4, factoring quadratic expressions. We're going to talk about factoring by the greatest common factor and grouping today. Now, there's two objectives we're going to look at most. First objective here is we're going to factor an expression using the greatest common factor, and then we're going to factor a polynomial expression using grouping. We're going to take care of these two objectives in this section. Okay. A couple of things that are important. We'll look at some vocabulary words first here, because these are going to really be important when we're doing this whole entire section. This section is broken up into a couple of different days. First vocabulary word we're going to look at is factors, and the definition of the word factors are numbers that multiply to become, let's cross that out there, to become a number. So these are numbers that multiply to become a number. This guy. A couple of examples of factors, like for example, if I had the number 15, factors of 15 would be 3 times 5. That would be an example of factors. If, for example, I take a variable x squared, factors of x squared would be x times x. Those are factors, numbers that multiply to become a larger number. Okay, second vocabulary word is factoring. This is rewriting an expression as a product of factors. Rewriting an expression as a product of factors. Now remember, an expression is any number of terms without an equal sign. So it could be numbers, could be variables. As long as it has an operation, it's considered as an expression, but it doesn't have an equal sign with it. So an example here of factoring, we're going to look at that a little bit more here coming up. But as I look at this expression, if I wanted to rewrite this, I'll give you an example here. If I had x squared plus x, and I wanted to factor this, you'll notice that both of these guys have an x in common. So I'm going to take an x away from each one of these, and I'm left with an x plus 1. And I'll explain more here in a little bit how exactly we do that process. But that's factoring. Next couple words here as we look at these. Polynomial. Polynomial. Definition of a polynomial is a monomial or sum of monomials. Okay, example of a polynomial. It could be one number, could be a 5, it could be a variable, it could be a couple of things like an x plus 5, or possibly an x squared plus 3x plus 5. It's a monomial, which we're going to get to here in a second. As a matter of fact, let's go ahead and talk about that. A monomial is a real number or variable or product of both. Now remember, product means to multiply. So it could be a real number, it could be a variable, or I could take the two things together, a number and a variable, and multiply them together. Okay, examples of monomials. These are one-term items. Okay, that's the key, is that there's one term. So it would be an x, that's a monomial, a y. I could do xy. That's a monomial. That's one term, x times y. Or I could do a 3x. I could do a x divided by 3. Again, that's one term. Mono means one. A binomial, okay, if you look at the beginning of this word, bi means two. So this is two monomials. Two monomials that are added or subtracted. Okay, two monomials that are added or subtracted. Example would be x plus 3. If I take a variable and I add it to a number, 3x minus 2 is a great example of a binomial, and x squared minus 4. That's a binomial. If you notice, you look at these two, you notice every time there's two terms. That's the key. So for a monomial, it had one term. Binomial, it has two terms. And if you look at the final word here, we've got trinomial, which means obviously that it's going to be three terms. So this has three terms. Separated by addition or subtraction. Okay, and that's the key, is that it has three terms. Okay, so an example of a trinomial could be x squared plus x plus 3. There's three terms here. These are your three terms with two operations. Okay, you could have something like this, x minus y plus 7. This has, again, these are the three terms, x, the y, and the 7, and it has two operations. Okay, so those are our vocabulary words for section 4.4. Now, let's take a look at going. Okay, so we're going to factor a polynomial using the greatest common factor. Greatest common factor is the biggest factor that will go into both numbers. Okay, so the two things we want to look at here in order to do this, to find the greatest common factor of all the terms. Okay, we want to figure out what is the biggest number that will go into all of our terms at the same time. Okay, and do all the terms have the same variable? So there's two things you're going to look for. You're going to look for numbers, you're going to look for variables. Okay, what's the biggest number that will go into all the terms? Or if all the terms have the same variable, we could factor that out as well. Okay, number 2 says, using the greatest common factor, well, once we find that GCF, we'll find that greatest common factor, you're going to divide all the numbers that are left over and you're going to subtract the exponents to figure out what's left over inside that parentheses. Okay, so essentially what you're going to do is you're going to take an expression and you're going to take something away from it. Okay, and you have to figure out what is left over. All right, let's go take a look at some of these examples. As you look at this example here, number 1, it says 6n squared plus 9n. Now, as you look at this, let's take a look at the first question. It says, what's the biggest number that will go into all the terms? So as you look at just the numbers, what's the biggest number that will go into 6 and 9? Okay, that's what you're trying to find. What's the biggest number that will go into 6 and 9. Okay? Well, the biggest number that will go into 6 and 9 is a 3. So I'm going to take and I'm going to write a 3 out front here, and I'm going to put some parentheses back behind because I got to figure out if I take a 3 away from each one of these terms. Remember, that's a binomial, it has two terms. I got to figure out what's going to be left over if I take a 3 away. Now, as you look at both of these terms, do all the terms have the same variable? And as you look at these two terms, both of these two terms have an n, at least an n. So I'm going to take an n out as well. Okay? So now once I've done that, what I'm going to do now is I'm taking a 3n away from each one of these terms. So I'm going to divide the numbers. So I take the numbers and I divide them. So 6 divided by 3 is 2. That goes there. Okay? And I'm going to subtract the exponents to figure out what's left over inside the parentheses. So up here, in this first term right here, I have 2 n's. Down here, I have 1 n. So if I take 2 n's minus 1 n, that gives me 1 n left over. And I have a plus sign there in the middle. Okay, so now again, take the numbers, 9, and divide the numbers. 9 divided by 3 is 3. And I subtract the exponents. Remember, if it doesn't have an exponent, it's actually understood to be a 1. So if I take 1 n away from this n, that leaves no n's left over. So my final factored answer is 3n times the quantity 2n plus 3. Okay, so now I have factored by the greatest common factor. Okay, let's take a look at example number 2. Now, as you look at example number 2, does each term have a variable? So as you look at these two terms don't both have variables, so I'm just going to look at what's the biggest number that goes into 7 and 21. Well, that happens to be the number 7. Okay, so I'm going to take out the number 7. So again, I'm going to take and divide the numbers. So 7 divided by 7 is 1. I have 2 n's up here up top. I don't have any n's left, so 2 minus 0 happens to be 2 n's. Okay, so there's 1 n squared. The minus sign comes down. 21 divided by 7 is 3, and there's no variables there. So the actual answer here is 7 times the quantity n squared minus 3. Okay. So let's take a look at example number 3 here. Okay, example number 3. Again, we have two-term item. Okay, as we look at this, what's the biggest number that will go into 25 and 20? And we come up with the number 5. 5 goes into both 25 and 20. And as you look, do both of these terms have a variable? And they do. They both have an x. So I'm going to take at least an x away from each one. So again, we're going to divide the numbers. 25 divided by 5 is 5. And I have 2 x's up top in the equation, or in the expression, and 1x down here. So 2 minus 1 is 1x left over. Bring down my sign. 20 divided by 5 is 4. And I have 1x. I subtract an x. That means I don't have any x's. So my final answer here is 5x times the quantity 5x minus 4. Take a look at this number 4 example here. Okay. Now, what's the biggest number? What's the number here in front of this x squared? As you look at this, there's a 1. So this is really 1x squared minus 2x. And you're going to ask yourself first, what's the biggest number that goes into 1 and 2? Well, there isn't one. So if there isn't a number that goes into both of these, we're going to take out a 1. So really, we're not even going to actually take out a number. But if you look at both these terms, do they both have a variable that's the same? They do. They both have an x that's the same. So we're going to take out an x, and we're going to figure out what's left over. So, again, the number that's in front of a variable is 1. 1 divided by 1 is 1. I have 2 x's here. I'm taking 1 away, and I only have 1 left over. So 2 minus 1 is 1. Bring down the sign. 2 divided by 1 is 2. I have 1x up top. I have 1x on the bottom. If I take 1 minus 1, that's 0. So I end up with x times the quantity 1x minus 2. Now, let's take a look at example number 5, because example number 5 is a little bit different. You'll notice example number 5 has 3 terms. We can still factor out a greatest common factor. Again, what's the biggest number that will go into 21, 35, and 28? Well, that case here is 7. So the biggest number that will go into all 3 of these is a 7. So I'm going to take out a 7. Factor out a 7. Okay. And do each one of these terms, do all 3 of these terms have a variable? And as you look at these 3 terms, yes, these 3 terms all have at least an h. so I'm going to take out an h as well. Okay, so 21, these are my three terms. Now I should have three terms in the parentheses. So 21 divided by 7 is 3. I have three h's up here. I'm taking one away. How many are left over? That leaves me with 2. So 3 minus 1 is 2. Bring down my plus sign. 35 divided by 7 is 5. I have two h's. I'm taking one away. That leaves me with one h left over. And 28 divided by 7 is 4. I have one h. I'm taking an h away. That doesn't have any h's left. And you're finished. So again, remember, you divide the numbers and you subtract the exponents of the variables. Okay. All right, let's look at our next set. We've gotten through factoring of greatest common factor. Now we're going to use that greatest common factor to factor a polynomial by grouping. Now you'll notice as you look down here at the bottom of the page, you'll see your example here, we have 4 terms. And you'll find out that not everything, they don't all have something in common. So the process we're going to use to factor by grouping is we're going to take each polynomial that has 4 terms. We're going to put parentheses around the first 2 terms and the last 2 terms. Then we're going to take those 2 binomials and we're going to find the greatest common factor of each set of parentheses and factor them out. Then we factor out the greatest common factor just like what we got done doing. Okay, again, if they don't have a greatest common factor, we're going to factor out a 1. Using each set of parentheses then, we're going to factor out what each term has in common. Okay, factor out what each term has in common. Usually, what's left over in the parentheses, so how that usually works. And then what's going to happen here is the first parentheses will usually be what you have in common. The second parentheses will be outside or what's left over. Okay, so let's take a look at this first example here, and let's go through with the directions. Okay, so first direction says put parentheses around the first 2 terms and the last 2 terms. So I'm going to put parentheses around here and around here. Okay, first 2 terms and last 2 terms, and you'll notice what that did for me is that created 2 binomials. Okay, created 2 binomials. So as you look at the first 2 terms, it says find the greatest common factor of each set of parentheses. So I take the first 2 terms and I find the greatest common factor. Now as you look at this, do they both have a number in common? No, but they do both have a variable and they both have an x. And you'll notice they each have at least an x squared. So that's what I'm going to take out. Okay, so 4 divided by 1 is 4. Okay, this process is no different than what we just got done doing with greatest common factor. I have 3 x's, I take 2 away, I still have an x left over. Minus sign goes there. I have 2 x's here. If I take 1 divided by 1 is 1. I have 2 x's, I'm taking 2 away, I don't have any left over. Okay, so as you look at these 2 numbers here, what is the biggest number that will go into 16 and 4? Well, that happens to be the number 4. Okay, so they have a 4 in common, so we're going to take that out. So again, 16 divided by 4 is 4. I have 1x up top. I don't have any on the bottom, so I'm going to have 1 left over. 1 minus 0 is 1. Bring down the sign. 4 divided by 4 is 1. And I don't have any variables, so I can close that parentheses. Now, it says up here, using each set of parentheses, factor out what each one has in common. Usually that's what's left over in the parentheses. If you look at these 2 terms, now you have 2 terms, what do they both share? Look at what's in the parentheses. They both have a 4x minus 1. That's what they have in common. That's what they both have. What's outside the parentheses or left over? That's an x squared plus 4. Okay, so now you've factored it, and you'll notice your answer is in 2 binomials. That's the key. 2 binomials. Okay, two binomials will be your answer. Two-term items being multiplied by each other. Okay, so that's the first example. Let's take a look at example number 2. Now, we've got a little bit bigger numbers, but that's not going to make any difference. We're still going to run the same process. So the first thing it said was to take and put parentheses around the first two terms and the last two terms. Okay, now we're going to do GCF, again, what we did before with these first two terms. What's the biggest number that goes into 35 and 30? Well, that happens to be the number 5. Also, between these two terms up top here, do they both have a variable? Well, they sure do. They both have an n, and they have at least an n squared. So we're going to take out a 5n squared. Again, divide the numbers, subtract the exponents. So 35 divided by 5 is 7. N cubed, that's 3 minus 2, n squared. Here, this, n cubed minus an n squared is 1n. Okay, bring down the sign. 30 divided by 5 is 6. And I've got 2 n's, subtract 2 n's away, I don't have any n's left over. Okay, bring down the sign in the middle. What's the biggest number that goes into 56 and 48? Happens to be the number 8. Do they both have variables? No, they don't, so I'm not going to take a variable out. Okay, now this is kind of where it gets a little bit tricky. Okay, so I'm going to take 56 divided by 8. 56 divided by 8 is 7. I have 1 n. I don't have any n's here, so 1 minus 0 is 1, so I still have an n. And then on this part, you'll notice this is a little bit different than the last problem, where the plus and the minus sign are kind of changed spots. When I do that, I've got to take positive 48 divided by negative 8, which gives me negative 6. And you'll notice, as you look at this now and you look at your two terms, you'll see that your two terms, what's inside the parentheses, they both have the same thing. So they both have a 7n minus 6. I'm factoring that out. What's outside the parentheses is 5n squared minus 8. And again, look at your answer. You have two binomials, or two things that are two terms. Okay? All right, let's take a look at our last example here. Sorry, second to last example. We'll go here with number 3. Again, first on the agenda, here's parentheses around the first two terms and the last two terms. Okay? As you look at the first two terms, what's the biggest number that goes into 1 and 4? Well, we don't have one. Do they both have letters? They do. They both have a b, and they have at least two b's. So we're going to take out a b squared. So 1 divided by 1 is 1. 3 b's minus 2 b's is 1 b left over. 4 divided by 1 is 4. And I have 2 b's, and I take 2 b's away. I don't have any b's left. Bring down the minus sign. What's the biggest number that goes into 1 and 4? That would be 1, because I don't have one. And you'll notice neither one of these have a b either. So they really don't have anything in common. If they don't have anything in common, we're... Okay, let's take a look at the last example here. Example number 4. And we're still going to use grouping, so the first thing we want to do here is parentheses around the first two, parentheses around the last two. And let's take and figure out what do these guys have in common in the first two. They don't have anything in common number-wise. Nothing goes into 8 and 1. But they do both have a variable. They both have an x, and they have at least two of them. I'll take out an x squared. So 8 divided by 1 is 8. I have 3 x's. I'm taking 2 away. I still have 1 left over. 1 divided by 1 is 1. And if you take 2 x's minus 2 x's, you don't have any x's left. Okay. What's the biggest number that goes into 24 and 3? Well, that happens to be a 3. And they both don't have variables, so we're not going to take out a variable. So 24 divided by 3 is 8. I have 1 x. I don't have any down here, so I still have it. Positive 3 divided by negative 3 is a negative 1. Now, again, looking at these two terms, what do they both have the same thing of? They both have the same thing of an 8x minus 1. And outside the parentheses, or what's left over, is an x squared. and a minus 3. And again, your answer is in the term of, in the position of two binomials. Okay? So that takes care of two things today in section 4.4, factoring by greatest common factor and factoring by grouping. With this material, you should be able to take care of what we're going to take care of in class today.